Hello everyone, this is Professor DePaulo and I'm going to walk you through this correlation and regression problem that I didn't have time for the other day and I've been trying to squeeze in the last day or so. So let's look at number 3 on the final exam review sheet. Cans of soda consumed daily and weight gain over 6 months were self-reported by 5 participants. And here's our data. So cans of soda consumed daily is our X and weight gain is our Y. And so I'm going to cut and paste this and put it into the put it into my whiteboard here. So I have the data. There's my data. Let me move this over if I can. So there's my X and Y. And the first thing I'm going to do to find the correlation is make an XY column. So I'm going to write here, next to my XY, I'm going to have an X squared column. I'm going to square the values of X in my X squared column. And I'm going to have a Y squared column, square those values of Y. My writing's not great, so bear with me on that. I'll try to write as neat as I can. And the next thing I'll do is I'm going to make an XY column and multiply each X by its corresponding Y value. And I have the 5 columns laid out like that. Once I'm finished with that, I can find the sum of all 5 columns. So sum of X, just add up all 5 columns, 7, 13, 10, 14. 10, 35, 39, and I will double check this. 4, 29, 65, 74, 90. And then the sum of XY here. So I'm just finding the sum of all 5 columns, 17, 47, 55. And that's what I have so far. Looks about right. So once I have those 5 sums, so these 5 columns, I can now start calculating other things. And let's start with SP, which is, of course, the numerator of the correlation coefficient, Pearson R. So we know SP is the sum of XY minus the sum of X times the sum of Y over N, like that. Our sum of XY is 55. Our sum of X is 11. Our sum of Y is 14, and our N is the number of pairs, and we have 1, 2, 3, 4, 5 pairs. So this gives us 55 minus 11 times 14, and to do that, we're going to go into, actually, posit cloud. So I'm going to go into R Cloud, which is basically the online version of R. And I'm going to do some of the calculations in here. Instead of using a calculator, obviously you're going to use a calculator, I'm going to use R. And R is something that I really wanted to get to this semester, but things did not go optimally, and I thought by introducing R, it was going to really be adding another layer of extreme difficulty. But R is something that you should really try to play around with. You can always reach out to me after the class and I can give you some things about R. Just to get used to it. It's free, it's very versatile, and it does lots of calculations. And I do the calculations here, which is mainly 14 times 11. That's 154 divided by 5. So we get 30.8. So back here, 30.8. That gives us 24.2 for SP. We need that. We also need sum of square x, which is sum of x squared minus sum of quantity x squared over n, which in this case will be sum of x squared is 39 minus sum of x, which is 11 squared over 5, which gives us 39 minus 121 over 5. That gives us 39 minus 121 over 5 is 24.2. Like that. 39 minus 24.2 is going to be 14.8. And then we're going to want to find sum of y, which is the sum of y squared. So this is just like what we did with variance way back when. We're just plugging in here 90 for y squared. Sum of y is 14 squared over 5. That gives me 90 minus 196 over 5. And that's going to give me 90 minus whatever that quotient is. Let's just double check. 14 squared is 196 divided by 5, 39.2. So let's do 39.2 here. And that's going to give us 50.8. So I have my two sum of squares, 14.8, 50.8. And just double checking that, 10, 35, 39. Okay, that looks good. We also want the mean of x and the mean of y for when we do the regression. So the mean of x is just the sum of x over n. So it's 11 over 5. So the mean of x is going to be 2.2. And the mean of y is going to be 14 over 5, sum of y over n. And that's going to be 2.8. And now we can calculate RR. The Pearson correlation is SP on top over square root sum of square x times sum of square y. So our SP on top, we have at 24.2. Our square root sum of square x, 14.8. Sum of square y is 50.8. So this gives us 24.2 over those things. When I multiply 14.8 times 50.8, 14.8 times 50.8, 751.84. So that's 24.2 over that mess. 751.84 square root. Let's do that. 751.84. That gives us 27.42 rounded. You want to keep these to two decimal places, to three if you can. But the third one here is 0, so I'm going to just leave it at 27.42. Right, now it's 24.2 over 27.42. 24.2 divided by 27.42 gives me 0.88. You could round the final answer to 2, and it's a 0.88. As my final correlation. And let's see if I have that data in here already. I think I do. 13502. Is that what we're looking at? Let's see. 13502. Yep. So I have that data already in here. And then if I do correlation XY, I get 0.88. So that's it. That's the correct answer. And that's our correlation. Now to convert this into the regression, we need to find B, which is the slope. And we know that B is equal to SP over the sum of squares of X, which in this case is 24.2 over sum of square X is 14.8. 24.2 over 14.8. Gives us 1.635. 1.635. Let's go there. Of course, I can't write on this thing. 1.635. Yay. And our y-intercept is going to be the mean of y minus b times the mean of x, which is going to be 2.8 minus 1.635 times the mean of x, which is 2.2. Solving for that, it's going to be 2.8 minus that product, 1.635 times 2.2. Which is 3.597. Let's go back there, 3.597. And then solving for that, 2.8 minus 3.597. That gives me negative 0.797. Negative 0.797. That's my y-intercept. So the line, the least squares regression line, y hat, is equal to 1.635x minus 0.797. There's your regression line. Now to plot it. So we're going to plot this. We need to plot our individual points in a scatter plot. So let's go back to our points. We have 1, 3, 5, 0, 2. So I'm just going to label from the lowest to the highest value. And I like to start at 0 if possible, which I can here. And the graph is not going to be some amazing graph. It's just going to be very basic. And so everyone's graph is going to look a little bit different. But the whole idea is that you understand the concept. So let's plot the points. So I have 5 pairs of points to plot right here. And I don't want to bring that all the way down. Okay, let's go. 1, 2. We got 1, 2 as a point. We got 3, 5 as a point. Put a dot there, put a dot there. 5, 6, 0, negative 3. So 5, 6 goes right here. 0, negative 3 is somewhere down here. It's off the graph. I'm going to put it in there anyway. And then 2, 4. So 4 of them are on the graph. This one's way out here off the graph. And I want a line to fit all of this. So let's do a line. Let's plug in for this line here. This regression line is going to be the best fit of this data. The first point you can plug in is the y-intercept, which is 0, comma, negative 0.797. So find 0, go down less than 1, sort of right here, put an X. And then I pick a point on the right side of the graph because I want one on the left side of the graph and one on the right side of the graph. So I'm going to pick 5, plug in 5 for this. 1.635 times 5. minus 0.797, and that gives me 7.378. 7.378. So find 5 and 7 up here, so it's kind of up here. And then connect those 2 points the best you can. And on the tablet, it's hard to draw a straight line. But something like that. That's your regression line. Now, what is the weight gain for a value of 5? 5 sodas. What's the Y, the number D? What's the weight gain for someone who consumes 5 sodas? So we already solved that because I plugged that in to find the point on the line. So it's right here. So if you consume 5 sodas, if X is 5, the Y value on the line is 7.378. So someone that consumes 5 sodas daily tends to gain 7.378 pounds. And that's it. You're done with your correlation regression problem. And so hopefully that is helpful. If you have any questions, please feel free to email me, and I'll see you soon for the exam.